how you did me wrong. That was wrong. And I learned how to get along and saw your back. From out of space. I just walked in to find you here with that bad look upon your face. I should have changed that stupid lock. I should have made you leave your key. If I'd have known for just 1 second you'd be back to bother me. Go on now, go. Walk out the door. Just turn around now. 'Cause you're not welcome anymore. Weren't you the one who tried to hurt me with goodbye? You got crumbled. You got laid down and died on your night.
Alright, you guys. Last chapter I'm going to do tonight, chapter 6. Okay, right underneath chapter 5. This part right here is not a question, but I wanted you to remember what correlation looks like. This is a very positive correlation, moderate positive correlation, moderate negative correlation. Take a minute if you need to pause this and just make sure you understand this. Also, on page 352 of your book, I'm not going to do it with you here, I'll mention it, but it starts, okay, it starts these bullet points. You're going to need to know all of these bullet points for what you're doing, okay? So make sure you're doing this. It doesn't end here. It's going to be on page, it's not on page 353, but there's some more correlation stuff. 354 is where it ends. And I promise you, on the test, they're going to ask you questions about what correlation means. So 352, 353, and 354, make sure you go over that stuff, okay? Now, last few questions for chapter 6. If you remember, I went over chapter 7 and 8 in class this morning, so I hope you had a chance to get the answers for that. They've been uploaded to the website. All right. The scatter plot above shows A, obviously positive. Okay, so you can cross out both of the negatives. And it's moderately strong. It doesn't look too weak, so let's go ahead and circle C. You just have to eyeball this, okay? The scatter plot above shows it's going to be negative, okay? And we're going to cross out the positive ones. And it's moderately strong. It's not the strongest negative relationship, but it's pretty strong. I'm going to go with B on that one, okay? At the bottom, I have typed these numbers into the calculator. Again, I need you guys to know how to use the calculator. You're not going to have time to do all this stuff by hand. So what I did is I went into stat, okay, entered this into my list. In L1 here are my GPAs. In L2 are the corresponding, is it SAT scores? All right. Question 13 wants the correlation coefficient R between these two things. So one thing you have to remember to do, or it's going to come up and you're going to be like, that doesn't give me the answer. And the reason that is because you have to make sure your diagnostics are on. We did a calculator corner about this. It's in your book. So you need to make sure you go to catalog, which is the second button, and then the 0 will get you to catalog. You need to go down to diagnostic. I'm going to just press D up here to get me to the D's, and then arrow down to diagnostic. Diagnostic on, okay? You must do that before this will work. Now you can go back to stat, calculate. I think I put my things into list 1 and list 2. Remember which one they are. Go down to this linear regression model. Enter. L1, L2. Okay, good. Remember the letter next to the X, whether it's A or B, there's a couple different ones that come up, is going to be your slope. This is your y-intercept. R squared is not what we're looking for. R, your coefficient, your correlation coefficient is 0.82, okay? Remember, R squared is going to give you the percent of how closely related they are. Just R is the correlation, so make sure you're answering the right question with R, 0.82. And hopefully that's one of our answers here, and it is. It's D, 0.82. I'm going to write on here because I'm going to upload this. Use your calculator. Diagnostic on. So if you don't watch the video, you might not understand what this means, but hopefully you watch the video. Okay, turn the page. Number 14, you compute the correlation coefficient between hours of TV watched and grade point average for a sample of college undergrads and obtain R equals negative 1.83. This means that, obviously, if you read the bullet points on page 352, the correlation has to be between negative 1 and 1. So this is obviously a mistake. You made an arithmetic mistake. Negative 1.83 is smaller than negative 1. And if you did try this on your own, I hope you did, you realized that I accidentally put this question twice. So hopefully you got it right the second time, if not the first time. And I wrote here this. You have to go over those bullet points, you guys. Please go back and read those for me, okay? Page 352. 15, an educator says that the correlation between students' grades and the type of music, rock, jazz, classical they prefer has a correlation coefficient of negative 0.7. Well, that just makes no sense because there's no number to make it negative or positive. Depending on where you would put those, well, you wouldn't to make a scatter plot. You can't use a scatter plot with categorical data. And even if you tried to, by putting them here, 1, 2, 3, if you put them backwards, instead of going jazz, rock, classical, if you put classical, rock, jazz, the correlation would be different. So I don't know how they got that. All right, that's obviously the educator is confused, like me sometimes, but not all the time. 16, a study of many countries finds a strong positive correlation between life expectancy in a country and the percentage of households in that country with telephones. This means that telephone use is a major contributing cause of a longer life. We don't know if it's causal if you use the telephone, so that's going to be no. There's other factors, what are they called, confounding factors, that will tell you that. Life expectancy could be significantly increased by installing more telephones. Again, that could be happening, but you don't know what's causing it yet, so you can't say that. In countries where life expectancy is high, telephone ownership tends to be low. In countries where telephone ownership is low, life expectancy tends to be high. Nope. So the answer is going to be none of these here. You compute the correlation coefficient between hours of TV watched and grade point average for a sample of college undergrads and obtain, oh, sorry, that's the same as number 14. An agricultural economist says that the correlation between corn prices and soybean prices is positive 0.7. This means that when corn prices are above average, soybean prices also tend to be above average. Remember, positive relationships are both going to be in the same direction, so they're both going to get lower at the same time, and they're both going to get higher at the same time. The correlation between height in inches and weight in pounds among first grade students at Happy Hollow Elementary is exactly 0.57. If heights are converted to centimeters and weights are converted to kilograms, what happens to the correlation between height and the weight of the first graders? The correlation is going to stay the same. That is also one of those bullet points. Correlation does not change when you change the units. All right, please go over those bullet points for me. All right, almost done. I know I'm going quickly, so if you need to pause and rewind, or if you want to, watch some other cool videos, let's get through chapter 6. Which of the following statements about correlation is false? All right, false. The value of the correlation coefficient is heavily influenced by outliers. That's true. Also one of the bullet points on page 352. The correlation coefficient can never be larger than 1. Again, true. The correlation coefficient measures how tightly the points in a scatter plot cluster around a straight point. True. And the correlation coefficient cannot be 0. That's false. It can be 0. It means there's no correlation. I think in your book, around on page 353, there's a picture of a 0 correlation, so look it up so you know what a 0 correlation looks like. It's just a bunch of scattered points. Okay. Investment advisors now often report correlations. For example, the correlation between gains and losses in large cap stocks and gains and losses in municipal bonds is R equals 0.45. So it's an okay correlation. It's not a seriously strong correlation. This means that the percent of changes in municipal bond performance that can be explained by the straight line relationship between municipal bonds and large cap stocks is, this is where we have to go back and use the R squared. R squared is going to be your percent, okay? Our R, our correlation, is 0.45. 0.45 squared is 0.2025, or approximately 20%, which is our answer D, okay? R squared is going to be the percent. Regular correlation is going to be how tightly they are, just like it says up here. Points are scattered in a straight line. Alright, so re-watch this if you need it. Again, this will just be uploaded with the answers if you want to go ahead and study that. And I will look forward to seeing you guys tomorrow.